In the previous lecture, we have discussed about the Benedict's spectrophotometer. Today we are going to discuss about the cyclodial focusing spectrometer. Each ion in this spectrometer describes a cycloidal path, the curvature of which depends upon the M/E ratio and the voltage we applied to the deflection plates. In the low mass range, the ions path are modified and the ions are focused on an auxiliary collector. Hence, beam of A given M/E ratio is automatically brought into the register of the collector as voltage is varied. This is governed by the equation M/E is equal to KH2 upon V, where K is a constant depend upon the geometry of the analyzer. The analyzer up to the mass 150 are possible with this instrument. The cycloidal analyzer has an advantage over the Dempster analyzer in that the focusing of ions beam in the former is independent on the velocity with which the ions enter the analyzer and also do not require the high electrostatic fields. The next spectrometer is radio frequency spectrometer. In this, the charged particle emerging from the ion source are accelerated to the same energy in an electrostatic fields. As assembly of the grids are employed to select ions accordingly to their velocity, on the beam of ions in the time with the radio frequency RF, field will be accelerated and emerge with the maximum energy and the velocity. The arrangement is so constructed that the ions having the maximum energy reach the detector and the mass spectrum is obtained by varying frequency M/E is equal to 0.266 mu frequency upon S square F square, where F is the frequency of 10 to 100 megahertz, S is the spacing between the adjacent grids in centimeter. Now, next is once we get the NMR spectroscopy from the recorder, how we can interpret the mass spectrum. So, next topic is the interpretation of mass spectra. The mass spectrum of a compound consists of a series of the lines corresponding to the mass of the ions fragment and the relative abundance of their ions and also that of the parent ion. So, you have a parent ion or the molecular base peak ion whose intensity is arbitrarily taken as the 100% and the other peaks will be find the relative intensities according to the parent ion peak. Once the spectrum of a compound is recorded, all the prominent peaks starting from the highest are tabulated along with the group. Laws to give these ion peaks are recorded as percentage of base peak. The peak intensities are also indicated as being in the one of the classes and their intensities are from 0 to 2% and 2 to 20%, 20 to 50% or 50 to 100% of base peak. From the available mass spectral data, all the possible structures are listed and checked against the actual spectrum. Actually, in the books there are a series of fragments according to their masses, losses in the mass spectroscopy. One can compare the structure from the tables which are available in the books and can find out the structure of their compound. Thank you.